So the first thing first, when we are drawing distance time graph, what do we place on x-axis? As we place time. So time is represented on x-axis, and the second thing, distance, which depends on the time, is represented on y-axis. So for the most part, time is the independent variable and distance is the dependent variable. In these graphs, it is assumed that the object is moving in a straight line unless mentioned otherwise. Hence, the terms distance and displacement can be used interchangeably. The next thing, these are very important pointers. The gradient of the distance time graph represents speed. How do we find the gradient? That's a separate thing. We'll discuss it afterwards. But the gradient would represent speed. And if we be more precise, the gradient of displacement time graph would represent velocity. Because displacement is vector, so its gradient would also be a vector. Now, what is gradient in simple words? Gradient in simple words is the steepness of the line. Gradient in simple words is steepness of the line. If the line is steeper, the gradient would be higher. If the line is less steep, the gradient would be lower. So steeper line means more of a vertical line, and less steep line means more of a horizontal line. So if we have a line that is purely horizontal, that looks like this, a horizontal line, for that line the gradient would be 0. And for a vertical line, if the line gets steeper, keeps getting more and more of a vertical, then the gradient increases. And if the line becomes purely vertical, the gradient becomes infinite. If the line is upside down, just like a slide down, if the line is upside down, for example, you draw a graph like this, time here, distance here, and the graph is something like this. The line is going upside down from a higher point towards a lower point. In that case, the gradient is negative. Up next, we have the formula which can be used to find the gradient. So gradient would be represented by m, and m equals to, one of the formula is to use this one, rise over run. The other formula is y equals to y2 minus y1 over x2 minus x1, which can also be written as y equals to change in y divided by change in x. How do we find change in y? Like this, y2 minus y1 divided by x2 minus x1. What are these things? These are the coordinates of the 2 points that we choose on the graph, and when we solve the question, I'll explain this thing. Let us compare the gradient of these these 4 lines. Which one of these 4 lines has no gradient, 0 gradient? C. Okay, for C, I'm going to write gradient equals to 0. Which one has infinite gradient? Okay, so gradient is infinite, undefined. If I compare A and B, which one has greater or higher gradient, A or B? Okay, so I'll be writing like this: gradient of A is greater than the gradient of B. So these are the prerequisites. These are the tools that you need to know before we start off with the graphs. And let's take a look at the first one. If the object is at rest, what does the distance time graph look like? So we're going to go through the distance time graph first. We have 1, 2, 3, 4 cases, then some combined cases, and afterwards we will move on towards speed time. So let's take a look at this one. So I'm going to place some of the data here, and we'll analyze the data to plot the graph. So when time was 0, the distance covered by the object was, let's say, 10 meters. After 1 second, it has still covered a distance of 10 meters. The overall distance is once again 10 meters. After 3 seconds, the overall distance is once again or still 10 meters. What does that mean? So this could be a track, it could be a road, something like this. And you see a vehicle on the road. Let's say the starting point is 0 meters. This is the reference point, and this point is 10 meters. So at 0 second, soon as you started to observe the vehicle, it had already covered a distance of 10 meters. After 1 second, still it is at the same distance. 2 seconds is still at the same distance. 3 seconds is still at the same distance. What does that mean, or what information about the vehicle do you get? Exactly. The vehicle is not moving at all. It's at the same position. So distance is not being covered. Whatever the distance was covered already, it's not changing anymore. So the vehicle must not be moving. And if I plot the point, for example, if this point represents 5, this one represents 10. So on x-axis, let's say this is 0, this is 1, this is 2, this is 3. I'm going to do it only for the first one. So the first point is 0 against 10. The second point is 1 against 10. The third point is 2 against 10. The fourth coordinate is 3 against 10. So let us plot these points. So the first one would be 0 against 10 would be someplace over here. 1 against 10 would be over here. 2 against 10 would be over here. 3 against 10 would be over here. If I join them with a straight line, it will look something like this. What do we know? The object, whenever the object is at rest, the distance time graph is a horizontal line. Whenever an object is at rest, distance time graph is a horizontal line. So what are the examples of this situation? Plenty of example. A parked vehicle, The distance does not change. Let's comment on the gradient. So what is the gradient of this red line? Should that be 0? Because it's just a horizontal line, so the gradient should be 0. And if the gradient is 0, and I'm going to scroll up to the important point, the gradient of distance time graph represents speed. So if the gradient is 0, speed would also be 0. Are we clear with the first one?
Yes.
All right. Let's move on to the next one. So now we have a situation. We assume the same vehicle, but this time the motion of the vehicle is slightly different. So let's say when we observed the vehicle at 0 second, it had covered no distance at all. The distance was 0 meters from a specific point from a reference point. After 1 second, it has now covered a distance of, let's say, 10 meters. After 2 seconds, it has covered a distance of an overall distance of 20 meters. And after 3 seconds, it has covered an overall distance of 30 meters. Is the object moving?
Yes, sir, it's moving.
It is moving. And matter of fact, this is why the distance is being covered. If the distance is being covered, the object has to be moving. So if I plot the points here, the graph would be something like this. So I'm not going to plot the points exactly. I'm just representing the shape, the overall shape. The overall shape of the graph would be something like this, which means the object is moving with a uniform speed. How do we know it's a uniform speed? Because,
Sir, as the distance is being covered, the same amount of time is being used.
yes, so equal distance is being covered in equal time intervals. After every second, the increase in distance is 10 meters. So it's moving with a uniform speed. So, what are the examples? So, we assume that the speed of the car does not change. Let's comment on the gradient of this graph. So, this line, is it going to have a gradient? And if
Yes,
yes,
sir.
the gradient would be positive or negative. What kind of gradient would be there?
Positive.
Positive. So the gradient would be, first of all, constant. Keep it in your mind. Whenever you have a straight line, the gradient would be constant. Whenever you have a straight line, the gradient would be constant. So we do have a straight line. So gradient is constant, and thereby the speed is also constant, which is the same thing as uniform speed. So the object is moving very smoothly and it's moving with the uniform speed. And if it is moving in a straight line, then we can also say the object is moving with uniform velocity if it is moving in a straight line also. And in the graphs, for the most part, unless mentioned otherwise, we assume that the object is traveling in a straight line and hence speed and velocity can be used interchangeably. Now on the same graph, I'm going to draw another one, and let's call this vehicle B. So I'm going to call this one vehicle A, the graph for the vehicle A, and then we have another graph for the vehicle B. And now the question is, how do we compare the motion of the graph, the motion of the vehicle A with the motion of the vehicle B?
Sir, the vehicle B is covering more distance in one time.
So, okay, that's perfect. Vehicle B is covering the distance faster. So, can I say the object B, the vehicle B, also has the uniform speed, but its uniform speed is more or greater than the uniform speed of A? So, two things. B also has uniform speed. Means its speed is also fixed. It's not being changed. Likewise, the speed of A is also fixed. It's not being changed. But the fixed speed of B is greater than the speed of A. So the speed of B, V sub B, is greater than the speed of A. V stands for speed, and then in the subscript represents the vehicle. The speed of B is greater than the speed of A. And whenever we look at the graph, since speed is represented by gradient in this case, so the one with the higher gradient would be traveling faster. So we can safely say the gradient of B is also greater than the gradient of A. You see, line B is steeper than the line A. And if the gradient is more, then the speed is also more. Alright, let's move on to the third case, which is when the object is accelerating. So let's say we have the same situation. We observe a vehicle at time t equals to 0. There was no distance covered at all. After 1 second, the distance was 10 meters. After 2 seconds, the overall distance was 25 meters. After 3 seconds, the overall distance was 50 meters. And for this one, I'll need to plot the point. So this one represents 0 on x-axis. This one is 1 on x-axis. This one is 2 on x-axis. And this one is 3 on x-axis. And let me plot the points for y. So let's go with 10, 20. I'll try to ensure we're marking with equal spacing as much as we can. I'm not using the ruler though, so it'll be an approximation. So what do we know about the vehicle? We'll comment afterwards, but let me draw the points first. The first point is 0 against 0. It would be located over here. 1 against 10 over here. 2 against 25. 25 in the middle of 20 and 30. Over here. 3 against 50 would be over here. Now the thing is, you cannot join these points with a straight line. Check it out. Can you join these points with a straight line? I cannot. So these points have to be drawn or have to be joined freehand. So it looks something like this. Kind of difficult for me to draw, but let's go with this trend. So you see, this time we don't have a straight line, we have a curve, and that curve is rising. What do we mean by rising curve? Means the gradient of the curve keeps increasing. It gets more and more vertical. It gets steeper and steeper. So you see, if you check out the data, in the first second, a distance of 10 meters was covered. In the next second, the change in distance was 15, and then the change in distance was 25. So with every second, the object is covering more distance in same time interval. So how is that possible? It's only possible if with every second the vehicle starts moving faster and faster. So what do we call this? If the object is moving faster and faster, it means its speed is being increased, and if the speed increases, we say the object is accelerating. Keep it in your mind, in these kind of situation, the graphs, speed and speed and velocity are the same thing. So velocity is increasing, the velocity is being changed, and the rate of change of velocity was known as acceleration. So the object is accelerating. So what about the gradient? What is our comment on the gradient? Is the gradient constant?
No, sir, it's increasing.
Okay, very good. It's not a straight line, so gradient is not constant. Matter of fact, gradient is increasing. And since the gradient of these graphs represents speed, so the speed is also increasing. And keep it in mind, I'm saying it again and again, in these kind of graphs, we assume the object is traveling in a straight line, and hence the speed would also mean velocity. So we can say the velocity of the object is increasing. It does not have a fixed velocity. And let me ask you the question, can you find the gradient of this graph? And before that, do you know how to find gradient in the first place?
Yes, sir.
Okay, so how can you find the gradient of this graph? So the thing is, when you have a curve, they always ask you to find gradient. Gradient I'm representing by M. They always ask you to find gradient of curve at a fixed point. So they're never going to ask you a general question, find the gradient of the graph, and the graph is a curve. That never happens. If they ask you to find the gradient in this case, they would specify the point at which they want you to find the gradient. For example, the question could be, find the gradient of the curve at t equals to 2 seconds. Just for an example, find gradient at t equals to 2 seconds. What do you do in that case? You draw a tangent at the given point, which I'll explain afterwards, but just giving you an indication. So let's say this is t equals to 2. You draw a tangent, and then A tangent is a straight line. You find the gradient of that tangent, and the gradient of that tangent would be the gradient of the curve at that given point. And then we have the last one, when the object is decelerating. So what does that mean? We started to observe a vehicle, the distance was 0, and then distance was 10, distance was 15, distance was 18. You see, the object is covering more and more distance. It's moving further and further away from your reference point. The reference point could be anything. It could be a starting point, could be anything. So it's moving further and further away from the reference point. But what's the pattern? The pattern is, with every second, it does cover the distance, but the rate of change of distance decreases. In the first second, it covered a distance of 10. In the next second, the change was only 5. In the third second, the change was only 3. So with every second, less distance is being covered. Although the distance is being covered, it is covering the distance, but with every second, less distance is being covered. So what does that mean? How is that possible? It is possible only if the vehicle is slowing down. So let's say this is a road and this is your vehicle at t equals to 0. T equals to 0, the vehicle was here. Then t equals to 1, the vehicle was here. T equals to 2, the vehicle was here. And at t equals to 3, the vehicle is over here. So you see, in the first second, from 0 to 1 second, in the first second, the distance is quite a lot, 10 meters from here to here. And in the next second, the distance was only 5. And in the next second, the distance was only 3 meters. So that means the object must be slowing down. And if it is traveling in a straight line, which we assume it is traveling in a straight line, we can say the velocity of the object decreases. And if you plot the points, the shape of the graph would be something like this. And what are the examples? A car applying the brakes. Gradient, is the gradient constant or variable?
Sir, it can vary, it can decrease.
Yes, for variable we have two options. It could be increasing, like in the previous example, the gradient was also variable, but in that case it was increasing. And in this case, the gradient once again is variable, but in this case it is decreasing. So if the gradient is being decreased, the speed would also be
Decrease.
decreasing. And if the object is traveling in a straight line, we can say the velocity is also decreasing.